Everyone, it's July 12th. All right, let's get this done. Course schedule, old problem. And after this, I'm gonna look into this. So we passed yesterday, but still need to see how other people solve it. So what is this? There are a total of num courses you have to take. Label from 0 to course minus 1. You're also given an array prerequisites. The prerequisites I is AI to BI indicates you must take course BI first if you want to take course AI. For example, the pair 01 indicates that to take course 0, you have to take course 1. Return true if you can finish all the courses, otherwise return false. Okay, I remember this problem, but I don't remember how I solved it. Too long time ago. Alright, so basically we have number of courses and we have prerequisites. So 10 means to take 1, you have to take 0 first. So to take 1, you have to take 0 first. Oh, topological sort. Topological sort. So 0 goes to 1, right? So you build a graph. So it's exactly the same as yesterday. You build a graph, right? And you will we need to build a graph. Yeah, 0 to 1. So we build a graph. 0 has 1, right? And then 0 has an we can say in edge, right? In edge. So in edge 0, 1, in edge 0, and then 1, in edge is 1. And then you take care of all of these. And then for everything on these, you go from this, you take something out. Yep, I think we can do with that. So it's the week. It's not a week. It's just gonna be a few topological sort. Okay, so what we're gonna do is going to be graph. Okay, default dict. Gonna go for prerequisites. So AB in prerequisites. Oh, and in degrees times num courses. Okay, so graph B dot append A, because you go from B to A, right? And then in degrees A plus equal 1. Then once we're done, right, we're gonna say Q equal to for I in range num courses if in degrees I is equal to 0, right? So we have I. And then we say can take false times num courses in degrees and can take. This is a Q. While Q, right? Temp for C in Q is a course. Then we say can take C equals true, right? And then after we take it, we go for child in graph C. That's called a course, right? Course. So the next class, the next course Okay. And the next course, we have to go, because I've taken this, so in degrees, next course minus equal 1, right? We say if in degrees next course equal to 0, temp.append next course, blah, blah, blah. Once we're done, q equal to temp. All right, once we're done, we need to say return sum can take equal to num course. Okay, let's take a look. Yep, let's try it. 2021, the last time. That was a long time ago. 2021, that's 2 years. Oh, 2 years ago. Okay, I saw it the last time too. 51 test cases. Check loop. I think that was the solution I figured out myself. So that was a different solution. Huh, that's all right. 52, one more test case. Topological sort, yep. Guess good technique, right? It's a good technique. M plus n. M equal to minus the length of edges. Topological sort. Oh, almost exactly the same. Oh, yeah, well, it's the same as yesterday. You can do DFS, right? You do DFS, you start from 1, right? You do DFS, okay? Yeah, you start from anyone, and if there's a cycle, right? If there's a cycle, then it's bad. You cannot do it. So we go. If we find a cycle, that is no good. We must go, and if we go to the end, so this is exactly the same as yesterday. Oh, nobody commented today. Oh, yeah. Yeah, I'm not gonna implement again. The most likely problem like this is I will go for topological sort for sure. So let's just leave it at that. Okay, we're done with this. Let's come here. Weird problem, 3 different. Oh, much simpler. Okay, if a string does not contain a palindrome, you can change its size to any character, providing this and this. Yes. So change will not produce any palindrome substring with 0 to I. That is correct. Here we can only increment. So we go right to left and we try to increment this to a valid character. If the resulting character is less, we fill the string on the right with the smallest non-palindrome substring. Okay, so how do you fill this then? The hell is this? Man, my C++ skill has dropped tremendously. I don't even understand. I have no clue. I have no clue what this one is. Dear me.
Our hair feels amazing. So much less tangled.
Oh, yeah.
Yeah, it's good. I got the haircut.
Yeah. You want to open the window?
No, it's so hot.
Okay. See, I don't know what this one is. Look at the syntax. Like, what the hell is this thing? I'm not researching this. I just want to see how he figured out the pattern. Yeah, so we go left, while. Oh, that is... No, wait, that's a... Holy crap, that's a function. That is a function. Dear me, that's a function. It's just to check if it's valid. If it's not valid, or if it's valid... Huh. That's a good check. That's basically this check, right? So if it's valid, we'll check if this is smaller than... Yeah, I mean, you can put this one here as well. But actually, I like this one. And then we'll fill out the remaining for... Oh, it's the same idea. It's the same idea, right? I think it's the same idea. Hold on. How can we just return S? S is a string. You can modify string directly. Huh, yeah. C at C, you can modify string directly. So we start from A. If it's not, so we just increment. Oh, I see. I see. Yeah, this is better. I was trying to figure out different types of patterns, but it turns out you can use the same logic. Yes. Now I like the other one. The other one is simple. Very simple. Yep, I like the other one. Okay, let's credit. Inspired by Voltruback.
I got selected.
Wait, oh, for the program to FAU?
Yeah.
Wonderful.
Oh, I spelled my name wrong. It said Rosa Lava.
You gotta let them know. You gotta let them know.
Me and someone else named Juan got selected for FAU.
Alright, so Juan probably from FAU as well.
I suppose.
Oh wow, wonderful. Oh, free trip. Free trip. Oh yes. Oh yes. That's great news. That's great news. Each solution also goes right to left.
Probably because I'm a female, maybe.
That could help. But yeah, they probably want one guy and one girl
Yeah.
for this.
I don't think so.
Oh yeah.
Uh,
Tell dad. Tell dad. He's.
well, in the video call, 'cause it's too complicated.
Oh yeah.
Playing over text, I think.
Yeah. He's gonna be wait, what's that word?
Ecstatic.
Ecstatic. Yes. Goes right to left. At each position, we check whether the current letter is valid. Right? If not valid, we increment it until we can't. At which time we move to the previous one. Now the check itself is not complicated. We already solved it, but he used a much cleaner way to express it. The real genius is that once a letter is confirmed, we can create the rest of the string on the right side using the exact same logic. In other words, we don't have to figure out the different patterns. Now it's going to be slower for sure, because the creation of the pattern because the creation of the pattern simplifies, right? Speeds up the creation, speeds up the filling of the rest of the string. But creating the rest of the string automatically is the real deal. It shouldn't say the real deal. This should be an optimization, right? But creating the rest of the string automatically should be the first solution, right? Should be the first solution, and figuring out the pattern should be a performance boost. Let's see if this one works, right? So yeah, definitely check. We have an index. No, you don't need index. We just need an index. What else do I need? I need an index, and I need the current letter. Okay, this one will give me a Boolean value. So I say if, maybe I can just return this one directly, right? Index if it's 1. So index smaller than 1. Actually, my index minus 1 is equal to 0, or we can say it's smaller than 0. If it's smaller than 0, it always works, right? So if this one's smaller than 1, or so index is equal to 1, so we can say ord s index minus 1 minus, oh, not equal to letter. Oh, not equal to letter. That I can do, right? So if it's smaller than 1, then we're good. So if it's larger or equal to 1, we have to do this. And so if this or this and index smaller than 2. So if 0, 1. Wait, hold on. It's smaller than 1, index is 0, right? It's smaller than 2, index is 1. Or, there we go. That's the one. Or s index minus 2 not equal to letter. Yeah, so we shall return this. So what we do, we say for I in range minus 1, minus 1, right? For each one, I say the current letter shall equal to current shall equal to ord si minus 97 plus 1. Okay, say while check current, if it's false, then current plus equal 1. So check should be this one, right? And with this, we just keep going until 1 is valid. Coming out, we say if current minus, no, it's already, this is minus 97. Why are you minus 97? Right? Let's don't minus 97. Let's just do this. So we say if current is smaller than k plus 97, that means we're good. Right? That means we're good. Now we need to form the remaining, right? And here, instead of doing all these work, what I can do, so I use the same idea. So we say for j, right? For j in range, so when you say the remaining, it's gonna be this. So for j in range I plus 1 all the way to the end. Ooh, I need to check. Oh, dear me. This is not... Alright, let's do this. Res s equal to list. Turn into a list. Now when I turn into a list, that's a different situation. We can do this, blah, blah. We don't need to do this. If this, then we say res s I shall equal to char current. And for this, right, we go from 0 up, right? When you say for k, now we have a k. So when you say for p in range 0 to 26, right? We say if check j letter is p plus 97. If this is good, then res sj equal to char p plus 97. Otherwise, we just keep going. One of them will work, right? One of them will work. Oh, not, it's k. It's k. But what if one of them doesn't work? No, it will always work. It will always work. As long as you can figure this one out, figure the current out, then the remaining will always work. So you just do this, right? You go through the remaining here, and then you fill it out, and we just return dot join res s, right? Otherwise, we'll return this. All right, take a look. Solution 2. Oh, I forgot one thing. Forgot the index. Oh, this one, did I forget index? I did not forget index next time. Okie dokie, what the hell? Oh, I forgot to break. Right, if this, we set it and then we'll break. Ooh, that is not right. That is not correct. How'd you get DBBB for this one? I should do this. Wait, hold on, I already did. Huh? Oh, it's not S. My bad. It's not S, it's res S. Yeah, I don't like res S. Let's change it to something else. List S, okay? Shall be list S. List S. There we go. I think this will be slower, but how much slower? Meh, about twice as slower. So maybe what we can do is try to figure this one out, right? So we know what this is. We know the current, we should know the previous one, and the previous one is always going to be like different situations. Okay, let's see. So this will be solution 3. Right, so solution 3 is the same as solution 2 to find the correct current letter, and then we use the pattern from solution 1 to speed things up. So we'll do this, okay? Actually, we don't need to do this because we're not doing the same stuff. So we do this, we do blah if. Okay, so now is the thing, okay? So we'll use this thing. Okay, so if I is smaller than 1, I is smaller than 1, and So current, so if current, then we say current letter is chr current. Now we say if current is equal to A, no, is equal to B, write pattern, otherwise write pattern, okay? Else, and we know it works, right? Else, if current is equal to B, now current letter is equal to B. Okay, our pattern shall equal to CAB if is I minus 1 is equal to A, else ACB, else our pattern shall equal to BAC if is I minus 1 is equal to A, else ABC. So that is the pattern. So this is if I'm at the front. If I'm at the front, then depends on what I am. If I'm B, so the remaining has to be ACB. So you probably can do this. Our pattern shall equal to ACB if current letter is equal to B, right? Else ABC. Else, if current letter is B, depending on the previous, if it's A, then I cannot do AB, right? It has to be CAB. Otherwise, ACB is the same, right? This one and this one is the same. Or in this case, the current is not B, so the previous A is going to be, this is the smallest, and otherwise is this. So we're going to return, oh, we have to do this div mod thing. So we'll just copy this. We'll do a div mod. Well, this is going to be len s. This is the remaining, right? Remaining we have, and then we go this, and we go this. So this is solution 3. That is not right. That is interesting to say the least. The current letter is... What? Are you kidding me, man? Current, yes, so I'll not true. I'll increment, right? If this is good, my. Current letter is supposed to be a D. Oh, I'm doing this again, so that's why it's wrong. Should be current letter. That's all right. That's all right. Okay, so that's all for this one. Yeah, I might just post something for fun. Find the triplet pattern on the right. I don't even know what this is. So the main idea, the main solution is borrowed from, let's post this. The main idea is borrowed from. Here, we offer is a slight performance boost. Considering the fact that the string on the right side, how do I say it? Considering the fact that the string to the right, the string to the right has a predefined pattern. The fact that a predefined pattern can be found depending on a predefined pattern. Oh, I don't even know how to express this. It's like performance boost. Suppose we have found the correct letter at position SI, then instead of computing the remaining letters to the right of index I, we can identify a triplet pattern, right? We can identify a repeating triplet pattern based on SI and SI minus 1 if it exists. If it exists, you can identify a repeating triplet pattern based on that will fill the space. That will fill the space of SI towards the end. This can, instead of computing remaining one by one, we can identify a repeating triplet pattern based on this. That will fill the space of this. Alright, so what my ideal is, we'll do this. Okay, we'll do this one here. Okay, let's see, we'll put the work. Currently our position is I. The pattern of this is deterministic based on what SI and SI are. Okay, this should be a lowercase I. Right, if current is B, It's different from your solution actually. It's different from the solution because the solution you check for I first. So I don't think this is right. I need to rewrite this. And here you actually check for I first as well. So actually we shall say if I minus 1 is smaller than 0, right? Then if current is equal to B, triplet shall equal to ACB, else triplet equal to ABC, else if current is equal to B, now we put this one at here. Awesome. If this is equal to A, then triplet, else, yeah, this one makes more sense. Let's use this. Let's use this. I found the correct letter position then instead of computer. Okay, let's post this and we are done. All right, let's just call it a day. Let's just call it a day. Hey guys, we have to start a new thing. Let's do it tomorrow. All right, I will see you guys tomorrow. Adios.